Hello everyone, welcome back to my YouTube channel. Today will be the first video which will give you the insight to the actual generative AI applications that we create. So we'll start with the LLM models that we have, right? So how an LLM model works is you have your application and it tries to interact with the LLM model you have. Now, this application could be your desktop application, your web application, your website, your agents, your agentic AI is anything that you have which tries to interact with your LLM model. So LLM model can be on your local system or it can be on a CPU or even self-hosted systems are there, right? Like you can interact with Gemini, you interact with OpenAI models. So anywhere it can be residing. So your application tries to access or tries to send request to LLM model. Request which you send can be a set of instruction, it could be a query, it could be a task which you send to LLM model. So this request is called a prompt, right? So your first keyword to understand is the prompt. The instruction or the query or the task which you are sending to AI in a defined format is called a prompt. And way you write a prompt is called prompt engineering. So this should be very clear. We'll have a separate video of how to design a prompt, but whatever instructions you are sending to AI, right, or a model is called a prompt. So AI LLM model does not manage your sessions. It does not remember your context also. It does not remember your history, right? Whatever request you send it, accordingly it will give you a response. Now, once the request reaches to LLM, how does an LLM model understand your request? So this is the higher overview of how an LLM model looks like. So if you go deeper into it or if you go to an architecture which represents the mathematical equation, that would be different. But on a higher language, this is how it works. Tokenization stage is there, embedding, transforming layers are there, and then you have an output. So what is tokenization? So see, whenever you understand some language, right, you understand it in a words, right? You understand the smallest unit you will understand is the word, then the sentence, paragraph, and whatever detail you have. So you have words and the context associated to it. But for LLM, words are not the basic unit. It is the tokens. So you convert that prompt or you convert that input into tokens. Why tokens? Because LLM can understand different language, right? Now each language will have its own set of words, right? Then say you are understanding English language. So English language cat and cats would be different. So you can imagine how many words LLM has to remember to understand that language. So and also say you have a new word which is not present in LLM's dictionary, right? Now those words you will not get any response for them. So to overcome this limitation or this situation, a tokenization concept was introduced. So you convert your or your sentence into a set of tokens. So say for example, you have Dolly is a language model that can help you generate text for a variety of tasks. This is the sentence which you provided. The system or the LLM model will convert this into token. So you can see that this in the middle, D is one token, Oli is another token, space is another. So whatever sentence you have, they gets divided into separate tokens. So say chat GPT, you are sending it. So chat would be one token, G would be one token, PT would be another token. So the length of the sentence and the total number of tokens might differ. Right? Depending on the model to model, this token may differ. And then these tokens are converted into numbers. Right? So it does not understand text, it understands numbers. Again, going deeper into how these numbers are getting understood will be the part of the, you can say, linear algebra, how it is understanding and all. But consider this, your text is converted into tokens and then those tokens are converted into numbers. There are different algorithms for tokenization. We will not discuss that because it will again go into deeper maths, and in some other video we will be discussing it. For now, you understand whatever prompt you send to the LLM model gets converted into tokens, and then those tokens get converted into numbers. So once you have those numbers, the, those numbers are called embeddings, right? You have predefined tokens in your dictionary that has already been provided, and then these embeddings are compared together, and then a context of that is formed, right? So you have sending, that is why the detailed prompt you write, the better context it could be provided. Now once that is set, there is a third step that is called attention. What it does, it do is it provides the weight of to different tokens in that set of prompt that you provided. So say, for example, you have provided the animal didn't cross the street because it was too tired. Now over here, what does it refers to? Does it refer to a street? Does it refer to cross? Does it refer to the animal? Because as a human, we understand, okay, it refers to animal here. But for the system does not understand what you mean by it over here. So this attention method tries to provide weight to different so this word, so you consider these tokens. So this sentence will convert into tokens, and then each token will be provided a weight. So it will understand, okay, the it refers to the animal over here. That is why this method or this step in the inside the LLM model is very important. Better the attention it will be able to provide the token weights, better will be your output. So that is why once you are sending the prompts, right, it has to be very descriptive, it has to be very clear, so that the output which you get is better for you. So this is why we emphasize on the prompt engineering. You write good prompt, and because LLM does not remember your context, so whatever context you need to provide, you need to provide it in your prompt itself so that the system understands it. So now attention is there, so different weights are provided, and then accordingly the tokens are getting generated. Remember in the second video we discussed this. LLM model is just the next token predictor for you. It does not understand anything, right? So it predicts something for you. So whatever context you have provided, whatever weights it has calculated, accordingly it will try generating the next token, that is the next suitable token. So similarly, it is creating the probability, finding out the which word will have the highest probability which can be added after this, right? So because it is working on the probability of those words that will come after that sentence, so you can able to control it. The way you control it is termed as temperature. So that is the word that they have provided as temperature. So if you keep a temperature low, so this temperature value varies from 0 to 1. So if you keep the value as 0, the highest probability word only you will get. So your output is not random, it is fixed, right? And if you keep as temperature as 1, so the value can differ from 0 to 1, any value it will take. So if you will keep it to a higher value, say to 1 or 0.9, right? So more number of words it will pick up, and then accordingly it will send. So each iteration will give you a new, so more creative LLM will become. But in the end, the next token is predicted. So because it is predicting your output, and now you get a response back. Because the system is predicting your output, right, in token, there is one problem which we've seen right now in variety of places is your hallucination. That's what we call as hallucination. So hallucination is, it may invent a new token to the context that you have provided. It will start appending that information also. So according to the system, it is the most apt thing, but according to you, if you see it in a whole picture, it might be a false information. So this is the hallucination, what we call it, that the system tries to generate some information which does not is not actually a fact. So that is why you have hallucination problems, and you have different ways to reduce this hallucination. See, you understand the logic, right? Why you are having hallucination? It's not that the wrong information system wants to give it to you. It is how it is being created. That is why you will see a set of scientists who are trying to see that don't go for data pattern, right? Don't try to find out the patterns in the data. Because once you're trying to find out patterns in the data, you are trying to predict the next word. So the probability could be false. I mean, whatever context the system understood, accordingly it is generating the data for you. So it might create a data which is not true. So not like the human mind that it creates the correct data, right? So hallucination is one of the primary things which is a drawback from the LLM model. So you need to keep the check of this hallucination. There are different ways to do that. We'll see it in the later video. But this is one of the things. So that is why currently in the news you would have seen, right, that Deloitte created a report which had false data. EY had some AI hallucination data, right? Hallucination is why? Because it is the data that is getting generated or the tokens that are getting generated are due to the probability it is working on. The maths concept is probability. So whichever word it sees as a higher probability, it adds it, right? So hallucination problem is there. Now, different LLM models that you can find. So some of them are mentioned over here, like OpenAI. The OpenAI model, you know, is that GPT or the Chat GPT, what we call it, right? You know it as them. Anthropic is has created Cloud. It has other LLM models also, Sonnet, Haiku also, but Cloud is famous. Then Meta has LLM. So in your WhatsApp, if you would have seen, there is a slight button that comes in, right? That is the Llama model. And Google is where you have a Gemini model, right? So these are some models developed by different companies which can be leveraged. There are again open source models also which you can leverage, but details are very huge. So you can find it on internet which model suits your requirement, right? Some requirement would be that okay, you want to generate an image. So some models might be suitable for that image, some other model will be suitable for the image, right? It does that comparison. Now, words to remember for you as you are starting your journey. So, these are the words which you should remember. You can go search these words and get a better understanding of them, right? So, these are the words you should start keeping in your mind or start creating your own playlist. And you know that these words you need to remember or you need to understand them. One is your prompts that we discussed. Context is in what scenario you are asking this question, that is the context. LLM models, now you know. Tokens, you know that your prompt which you are sending or the instruction which you are sending gets converted into tokens, and then those tokens are converted into numbers, numerical representation, right? So tokens are the basic building blocks on which LLM works. So one token LLM will understand the unit, basic unit which LLM understand is tokens. Hallucinations, you already know. Self attention, you know it. Try to adjust the weight in your prompt. Embeddings, once the token is converted into numerical representation, those are called embeddings. Temperature is how you control your output, right? How much randomness you want in your output, how much creativity. More the randomness, more would be the creativity, but more will be the hallucination. Again, depends what you want. And chatbot. Chatbot is when you have a conversation. So you remember we talked about LLM model does not remember your conversation or your history or your context. So what happens is if you create a chatbot to converse to the LLM model, right? In chatbot, what happens is you you create one prompt, you send it, and you got a response. Then you again write something like in chatgpt.com when you use it on the console, right? You can converse with it. So that is the chatbot system. So in that, what happens is you take the earlier prompts that were given, you put it in your one prompt, and then you send it to chat the LLM model. Different ways to send the information, but in the end, you are sending that information. LLM model is understanding and giving you the output. Hopefully, this would have been a very beneficial video. Keep all those keywords in your mind. Try to Google it out and see what do they mean, and then we'll meet again in the next video. Which and so from today we are starting the actual generative AI. The earlier videos that were there, just an introduction to the mm, domain of AI, you can say. Now this is where we are actually understanding Gen AI. So these keywords which you saw, right, are important. We will be using them. So as a beginner, keep these things in mind and how to understand we have already discussed. Hopefully this video was helpful for you. So please do like, share and subscribe, and also please comment it out. If you want some particular words to be explained or for some particular concept to be explained again, you can let me know and I can post that video for you. So thank you.